right, I think we're ready. Today we're going to do a mod that's pretty popular, an upgrade that's pretty popular. We're going to add in the BLTouch to our Ender 3. Our Ender 3 has the version 4.2.2 board, and that particular board has a plugin that's specifically for BLTouch. Now, the BLTouch that we got doesn't exactly have that plug on it, but it'll be fine. We'll show you how to kind of mix a little bit older style cable with the more current version of the board, although there are even more current versions of the board than 2.2. But the Ender 3s that aren't pros and version 2s and that, they come with this board, and it has a port, or it should. I actually haven't checked, but it should have a port on it where we can plug the BLTouch directly into it. Now, if you have one of the older boards, the 8-bit boards, the 1. I don't remember what their number is, 1.5, something like that. This kit does come with a way to use that also. There's a little bit more involved if you have one of the 1.0 style boards, or 1. anything style board. They don't have a dedicated port, and you sort of have to do some other things. You have to install a bootloader, for instance, to get the firmware up to date. We are going to have to update firmware because we're adding new hardware that's not just passive. This is an active piece of technology that has to integrate with the firmware. So we do have to change our firmware. I'm going to go back now and use the TH3D unified firmware because it's really easy for that one to add in the sensor, the BLTouch sensor. Or any of they actually have it set up to where it's easy to add many of the sensors. So first, let's look at the sensor itself. Let's do that first. Oh, well, actually before that, since it's on the screen, I did add this guy. So this is has a knob so that you can tension this belt. I printed this in PLA, so it's probably a little bit weaker than it should be. In fact, this spot right here, right there, is really weak, and it did crack when I installed this screw. The one going across here, it cracked right. I don't even see the crack anymore, but somewhere in this thin area it cracked. Now everything's in compression on this piece, so it's holding in there, and I did glue it, and so far it hasn't released. So you can just change the tension on your belt by turning this knob. It's really loose, and you can tighten it up. I don't know if I will keep this on here in PLA for sure. It might over time creep to the point that it doesn't work at all anymore. But it printed fine. This is where I got it from. I got it from Thingiverse. This one right here, the Y-axis tensioner. The only thing, so it uses the hardware that you already have on here. The only thing that you have to be aware of is this hex key right here is not one of the sizes that come with your kit. So this is the largest that comes with your kit, and it's too small. So you do have to have, if yours is the same as mine, you do have to have a hex key that can actually loosen this, or you can't get it off in the first place. This is already on the existing mount, and there's several of these. It only uses one on each side. I think there were two at least. Yeah, there were two on each side before. It does work. PLA is probably not the best material for it for long term, but it did print and it did work fine. This part is threaded, so you do have to have your printer relatively dialed in order for the threads to mesh between the knob and the piece that moves back and forth is the matching threads. So you do have to have that set up. I also printed this. If you remember, this particular model has a fan on top with an open grate. Now, a lot of the newer ones, the fan is on bottom, and this isn't an issue. But this one, there's an open hole right here with a fan in it, and all sorts of stuff can fall in there. And so I just printed this. This one I'll come back to later because it did fail. The print failed. You can't really tell on the, maybe if I zoom in, you might be able to tell. Yeah, you can see it, I think. Yeah, there we go. So right here, it came loose, or I think the print head hit it while it was printing, or something happened to it, and I wasn't watching it. So it printed from here. It was standing up. This was on the bottom of the print bed. It could have just not been much area holding it on the bottom, and it just came loose possibly. But anyway, it got to right here and failed, and so this little piece here didn't print. Because the part had moved off the bed and it couldn't print in midair. So I'll show you later on, maybe not today, we probably won't have time, but I'll show you how to measure what you did get, go into your slicer, drop the part down that far, and then print the remainder and glue them together. And actually that's all there is to it. There's not a whole lot to show you other than actually how it worked. I also got these in. Oh, we're zoomed in too far. So here's our kit right here. We may have to zoom out. Let's get it to look the right direction too. So this is the kit I got both off of Amazon. I also went and ordered these. These are silicone mounts to replace the bed springs. They have some amount of give to them, but not like the springs do. And now that we're going to have a sensor on here on our bed, on the printer that senses the bed, I'd rather have the bed as rigidly mounted as possible so that it's not moving around, vibrating. I don't run the risk of, during printing quickly or fast and the springs vibrating. I want to put these on there. Now this, I might run into issue because remember I put the magnetic bed on here that covers up the screw head for the screws that are holding the springs down currently. I need to reuse those and replace the springs with these, and it might give me a little bit of trouble. We'll see. We'll figure it out one way or the other. So these are like $10. You can print these. These are silicone, and you can print. We haven't done any yet, but you can print flexible material. You can print them in PLA. You would run a little bit of a risk printing them in something like PLA because you a lot of times are going to heat the bed to a temperature that's close, and in some cases even above, the heat deflection temperature, the glass transition temperature for PLA. And so then they would begin to deform potentially, and then your bed would be all messed up. So, or at least the level would be all messed up. So these, they're not terribly expensive, and so I will hopefully be replacing them, replacing the springs with these in a minute. Here's the BLTouch. So it comes with a little bit of instructions. We may look at that. I don't know. Here it comes with a mount right here. So this mount is one of the reasons I like this kit, is that it has a mount that you don't have to go print one. Now the earlier versions, all you got was the cable and the BLTouch. This is the sensor itself down in here. I'll get it out in a second. I don't want to mess it up. So I like having the mount. It's a metal mount, so you don't have to worry about it moving around on you. And it just uses existing holes on your carriage. So I like that. This little guy is, the combination here is, if you have the older style board, you can use these to plug in or tap into basically where the LCD ribbon cable goes. You can use that and not have to try and rewire it. The very first one of these I did, I had to actually go in and strip a piece of wire back and patch into it, solder it in place, and it worked fine. But these are much simpler. We shouldn't need these, but if you have an older board, one of the version 1.0 8-bit boards, you probably will need these. I assume these would still work. The downside to using these is that they take over pin 27 on your, basically the board here is running an Arduino, and that pin 27 is running the beeper on your LCD. So every time you, sometimes you have it set up where it clicks or it makes a sound when you make a selection on the LCD. You'll lose that. Not a big deal, but you will lose that if you use one of these style things. Here's the cable that we got. So we have a cable that on one end It's going to plug directly into the BLTouch. It's going to plug in here. It only goes one direction, so that kind of solves an issue of, which way does it go. A little bit easier to go ahead and plug that in before you mount the BLTouch, if possible. And some of them have a similar but larger end on here. This particular one has the split end where these 3 wires are the power, ground, and signal wire for the BLTouch itself. And these 2 are going to make it act like the Z end stop, the white and black wires here. So that's the one I have. I don't even know if you get to choose when you're buying one of these. When you buy one of the kits, the kit itself is around $40 or so, somewhere in that price range. They probably vary. I think actually I looked, let's see, and there's some 54. There's a Prime Day deal for $40 for basically, it looks like more or less the kit that I have here. Well, actually, I think I have this kit because I have these adapters in it. So $42, somewhere in that range. You can get the sensor itself in a knockoff brand. I'm just always a little bit hesitant of using the knockoff version of the BLTouch. I haven't ever actually used it, so I can't say that they're bad. I've just always used the actual Ant Labs. So, or I don't know how you say it, but it's ANTC Lab. I'll see if I can get this out of here so we can look at it. This little guy here, this is if you need to install a bootloader or you don't have a bootloader on your board. So this and these are for if you have the older version 1 board. So we shouldn't need those. I do have videos from the past, maybe even last year or maybe the year before. I don't remember, but I do have a video out there if you need to install a bootloader on how to do that. You basically need your own Arduino Uno and use it to patch into your board on your printer and have it install a bootloader. It's a process. It's not. It seems much more complicated than it actually is, but it does require some special things like an Arduino and some special patch wires that you might have to make or find. I made mine, but looks like we have some hardware in here. Maybe now we can finally get down to getting this. Oh, it doesn't have. So there's a little plastic tip on this end that I'm trying not to bend up, because then we will have problems. There we go. And there's a spare one of the tips underneath there. Definitely want to keep that. And so this is the BLTouch itself. It looks like, I think, well, it's hard to read, but I think it says version 3.1 right here. So that's one of the newer ones. And then there's the actual brand name of this particular one. And now, like I said, they do make knockoffs that are somewhat cheaper. All right, so why don't we look at our firmware first, because it's going to have to compile. And so while it's compiling, we can be mounting this stuff up and kind of save a little bit of time. So let's move over to our firmware. Where do I have it? Here it is. Well, let's start from the beginning. I've already got it open here, so let's start from the beginning. So let's close this folder. I don't know what changes it made, so I'm a little hesitant to save them. Let's not save them because I don't really know what they were. So here is, well, let's actually look at the TH3D Unified Firmware is what I'm going to search for. There it is. Actually, I want Unified 2 because we're installed on a 32-bit board. And so that's Marlin 2 basically is what this Unified 2 firmware. Download site. This is where you have all the little different printers. I remember when we did Marlin, you do a similar thing. You download Marlin and then you get a configuration file for your printer and replace the configuration.h and configuration.advanced.h with those particular files. Here, the way they've done it is they've just sort of given you all the printers that you might work with. Here's some CR10s. That's getting close. So here's our Creality 3, and they've already made those specific changes. And we would want this one. Creality Ender 3 or the 3 Pro with the 4.2.x, so that could be either 0.2 or 0.7 board. So I downloaded this, and you can kind of see there's a download for it. And once you download it, downloads into a zip file. You extract the zip file, and then you go over here. We're in Visual Studio Code now, so no longer are we coding over an Arduino IDE. We need to use the Visual Studio Code, or well, something like it anyway. So File, Open Folder. I put this on the desktop, and it's the TH3D. In the firmware folder, there you can see Marlin, so that's what we want to open. And then it's going to open configuration.h, configuration.advanced.h, and it'll open the Platformio. So this is assuming you've already installed VS Code, Visual Studio Code, and set it up. I think, let's see. Yeah, they have an installation guide here if you haven't done that. So on this th3dstudio.com page that we were just at, where the firmware is, they do have a VS Code installation guide if you haven't already done that. It's basically download it, extract it, take all the options, and install it. So here's the platform IO. I don't need that. I need configuration.h. Now, if you're unsure what to change here, they do have, let's see. Yeah, here is the BLTouch Creality version 4.2.2. That's the board we have. You might have the 2.7 if you have one of the version 2 or the Pro Ender 3s. I just have the basic one. And so here are the BLTouch wiring options for that. And I think I found this. You could either work your way through their website. I think I actually searched for Creality 422 TH3D. I think I searched for that and it came up. So here's the header that we're going to be looking for. If we had the 5-pin header, we could just plug it in right here on our cable. But we have the 3+2, which equals 5, but they don't plug in side by side. So we're going to have to plug in 3 of the wires here. You notice the G, V, and N. That's the ground voltage in and the signal in. We'll plug in 3 of the wires here, and then I think it's this one. I can't really see. They've got this red line over it, but I'm pretty sure this is the Z in stop, where we'll plug in the 2 that are together, the black and white wire. Here are the things we need to do to the firmware to activate the fact that we have a BLTouch. So you can do similar things in Marlin. So if you want to stick with Marlin for some reason, then the basic Marlin 2.0, not this version of it, then you would search for Marlin 2.0 BLTouch, and there'll be a guide similar to this, and it'll tell you the exact lines to uncomment or to write in that version of the code. I think this one's just cleaner, and I just like it a little bit more. And I'm maybe just because I'm more familiar with it, but there are many different flavors of firmware, even flavors built on the same Marlin. All right, so we need to go into configuration.h, where we're at over here. Splash me. And we need 3, actually we only need 2 lines. So this Creality BLTouch on 5-pin, that's if you have the header that actually plugs all 5 into this one little port. We don't have that, so we don't need to modify or enable this line. We need to actually make sure it's disabled. So let's just look for BLTouch first. So let's Control F. Well, hold on, Control F, and we will find BLTouch. And let's see what we have here. So here's the section for BLTouch. It even describes there are 2 ways to connect it to the 4.2.x boards. That's where I found. That's actually where I found it right there. That link is the link to this setup guide that we're looking at. All right, so here we go. This is the line for if we have the 5-pin connector. Since we don't, we're going to leave that one commented out. But here's the line, define BLTouch. So we want that to be true. We have a BLTouch. Now, I believe I have already set this this software or this firmware. Yeah, I've already set it up as far as it knows that we have a 4.2.2 board. So the very first thing, if this is the first time you're installing this particular firmware, you do have to go in and select what board you want to work on, because this one set will do the 4.2.2 board, or the Ender 3 Max, which has a little bit different stepper drivers on it, the version 2, and then the Ender 5 all can use this 4.2, and then here's the 4.2.7 boards. So you do have to, all of these are commented out at the beginning. So if you haven't done anything with this firmware, you're downloading it for the first time right now, the very first thing you need to do is go pick which printer and board that you have and uncomment that, because it'll start out like this, and you need to uncomment that before anything is going to work. The other thing that I did, remember, is I did go in and do the custom E-steps. If I can find them. Here they are. By default, this is commented out, and I went in and changed it to my calibrated E-step number, 97.7. By default, it's going to be 93, and it'll still work. It just might not be calibrated right. And then if you wanted to insert your PID tuning, you could do that too also. I didn't do that. All right, back to the BLTouch. I just figured I should make that announcement, because if you just start right here and you haven't done these other things, it won't even it won't be firmware at all, because it doesn't know what printer it's talking to. So define BLTouch, we did that. We don't need, in our case, to define this one. This one, remember, we had the manual mesh leveling turned on. Now I don't really need that, so I'm going to uncomment that. This one should already be uncommented, inactive, if you are downloading this for the first time. This was not the first time I downloaded this one, so I had already used it before. Let's see, so we don't need that. These are options for that have to do with the BLTouch, and so I'm just searching through them to see what might pop up. Doesn't look like anything. So custom probe, we need to find that. So we're going to search for custom probe. There it is. So first of all, we want to define custom probe. So this software, or this firmware from TH3D, they do have their own sensors that they sell. There are different styles of these sensors. So the BLTouch is mechanical in nature. It has a probe that actually goes and touches the bed. But there are some no contact probes, some inductive sensors, capacitive sensors, different styles of sensors. And TH3D has one. I believe theirs is probably inductive. I'm not sure which one it is, but they do have their own probe. And so you can kind of see they've got some different setups here for probes already kind of prepared. We want the custom probe, and let's see, that all this did is activate custom probe. We need to go and set up the custom probe. I just misspelled it. So here is kind of this if enabled custom probe, which we just enabled. So this is now active, except these are all comments. All of this is describing what they're trying to get you to do. So when we mount this, let's see if we can get all these off. When we mount the sensor, it's going to end up over here. It's going to end up about right here. And so the probing is going to happen over here somewhere, and the nozzle is actually over here. So there's some distance between the nozzle and the sensing, and so to account for that, because what the whole goal of this sensor is to map the bed so that you can adjust for waviness or unevenness in the bed as you're printing. Like the printer will automatically do that. It'll move the print head up and down to kind of trace over waves in your bed, and if it's off by 40 millimeters or whatever, then that mapping is going to be off also. So this custom probe, setup is telling the software where is the probe in relation to the print head. And so that's kind of what they've got here. This N is the nozzle, and then are you on the left side? We're going to be on the left side, so we're going to be a negative X, and then are you behind it or in front of it with the probe. Now, the other thing I like about this particular setup is that since it's a rigid setup, you know, there's a metal bracket here that's going to mount the probe the same every time. Then we can actually already know those numbers. We could go measure them, you know, measure the distance between the probe tip and the nozzle, but they're already defined for us. And I think, let's see, yes, if you're using the Creality metal BLTouch bracket, which we are, then you can, the offsets are in our Help Center article. So we can just look there, and here are the offsets. Nozzle to probe offset is negative 44 millimeters, so it's 44 millimeters to the left, and negative 9 millimeters. It even shows a picture of how it's going to be mounted. Negative 9 millimeters, so that's 9 millimeters in front of the nozzle. So down here, it's set up at 1010, which would put it, you know, to the right and behind the nozzle, which is definitely not right. So we're just going to replace this with negative 44 and negative 9. We're going to leave the Z at 0 and adjust for that separately later. It will be about 3 millimeters above. Well, when it's retracted, it'll be about 3 millimeters above, and then when it's extended, it'll obviously be below the nozzle, and we'll allow for that later. So that's nozzle to probe offset. Let's see, what other things did it say? Again, we don't need this one. We have modified our offsets in custom probe. Here what they're telling us is that sometimes, and I've had this, and if you watch one of my older videos on this, even last year I think this happened. Sometimes the order of these wires on here combined with how they come out in this pin isn't going to work. In fact, I'm looking at this and I don't think this is going to work the way it is. And so we might have to rearrange the order here. This order looks fine. So typically what we're looking for is white and black, and with white on the outside here. The signal wire, which is not always yellow, but it's often yellow, being in the middle. And then we want a power wire, and in this case they're using blue for ground. Some of the others I think maybe have a brown color for brown. This one uses blue. So this is wired correctly, and so it's going to plug in here like so. If I can get it to plug in. Actually, I think it plugs in this way. Got to get it sorted out which way is going to be right. Let's see. I don't think it's actually working out for me. I don't think it goes, it shouldn't go this way. I think it does go this way. I'm just very tiny. And this is why it might make the mounting of this a little bit more difficult with the wires already here, but it's really hard to install this or plug this wire in later. And I'm going to have to move it off camera so I can actually see what I'm doing. Let's see. Why are we having trouble? Wow, this one is... Oh, I see what's the issue. The little socket back here is bowed a little bit, and so I'm going to have a little bit of trouble getting it all lined up just right. I think we got it here, now that I knew that's what the problem was. All right, so we're plugged in. This part should be fine. Let's go ahead and mount it on here. So we need to remove these two screws, and it's just going to mount in their place. Now, they do give us slightly longer new screws to replace this with. A lot of times I use the existing ones, but since they gave us some longer screws, we'll use that. You do have to be careful to make sure you don't use screws that are so long that they would actually go through and touch the rail that it's riding on. I don't think that's going to be a problem, but just be aware that that could happen. Oh, it landed in the rail, of course. This is another reason I keep these things around. There we go. They do make inserts, colored inserts for these rails. Some printers come with them already. You can print them if you really wanted to, and that would keep stuff from falling in there. All right, so I'm using the little bit longer screws. I'm going to mount this bracket. It's got a cutout for this spot here. Now at this point we have the choice. We could go ahead and mount this guy on here. I don't know that that's going to be our best option because it makes this getting to this screw really difficult. So I'm going to elect to try to mount the bracket first, and then we'll work on putting the sensor itself on there. So we'll get that started. Don't tighten them all up until you've got everything lined up to begin with. Okay, that seems fine. Now we can tighten those down. Everything still moves. The BLTouch, the wire is going to go back behind here. And for now, we're just going to leave the wire kind of unattached. They do give us zip ties that we can zip tie it to the existing wires that are already running down to the motherboard. We will leave that be for now. They gave us a little set of screws, which I think are identical to the screws we took out of here to mount the BLTouch with, but I will use their screws just in case they are slightly different, but they look exactly the same to me. I think they are. All right, so the way we need to do this is a little bit tricky, but not terribly. Kind of like that. And the other one is going to go back here. All right, so here we should be good now to take our cover off of our motherboard down here and plug in. Oh, you know what I didn't do? I said I was going to do it. This was the whole reason we were working on this code, was that I was going to let it compile. Let's go ahead and start this compiling, and we will. Doesn't show any errors. We'll click this little check mark down here in the build. Is that on? Yeah, that's on the build on the screen, and we will let it start to compile our software. Hopefully. All right. Looks like it's going relatively well. We need to remove this cover. So we're going to take this longer screw out of the back, and then we're going to, let's see, so you can see where I'm doing this. For now, we're just going to kind of zip tie. I'm not going to do it yet, but we're going to zip tie this BLTouch cable to our existing set of cable. There are many options on what you can do there. Right now, we're going to do the really cheap, quick option and just kind of zip tie it in place once we get it in place. All right, let's go back down here. Let's get these off. Oh, not break it. So there was the fan that was just completely open. A lot of the newer printers don't have this open on the top anymore, but this one does. All right. So here is what we're looking at. Let's see if we can get down in there to see. All right, so there is that header that if we had the 5-pin header available, we could just plug into that. But ours has the 3+2. But here's our problem. So can you see this? I don't know if you can see it. Well, you'll have to trust me. On top of here, right above this, written on the board, is the pin out for these pins, and it says GVN. So just like this picture that we had, right? Right here, GVN, G out. So it's expecting the ground to be the leftmost pin, and this is something you have to check. Remember, the ground on our wires is blue. And so when we find this is what's supposed to plug in there. And ground is the middle pin. And red is the outside pin. So it wants to plug in like this, but that's going to put red on the outside when it needs to be the ground, and red is our power. So we need to flip these two around. And it's not impossible to do, but it's a little bit tricky. So there is, I'm actually zoomed in too close, I think, for doing this. So there's a little tab, right? And there's probably a tool that does this, but I'm using my tweezers. So that little tab, you can lift it up, and then you can pull out the fending wire and do the same thing with the other one. And then you can just put them back in the order you want them in, and they just snap in. They will click into place once you get them seated far enough. There it goes. Now, don't bend these little black tabs up too far that you stress them and like deform them, because then they won't. I don't know if you can see this or not, but yeah, I don't know if you're going to be able to. I'll try to zoom in. All right. You can sort of see there on top along there, that is the little tab that's going to catch behind this black plastic tab right there. And so you do have to orient this correctly for it to actually catch behind there. And see, once it goes past it, then assuming you haven't like deformed the black plastic up, then it'll lock in place. Now we've got our blue wire ground on the outside to match up with, hey, you can kind of see, you can see them now, GVN. So we're going to plug that in there. And those should line up correctly. Now we've got to get, and you can pull these apart to get some extra room. We've got to get these guys in. So this is basically replacing the Z end stop. All right, our firmware did succeed, so that's a good sign. So these are all of our end stops over here. We need to get this out of the way. Also, remember there's going to be a fan right in this area, so we kind of want this to not have wires that will stick up into the fan, because it'll be annoying if nothing else. Now these, let's see, yeah, you can see Z clearly right there, plus it's going to be labeled on this yellow little tag. Normally you would just pull those out, except that they've done a good thing, but it's annoying. All of the sockets that are plugged in from the factory have hot glue holding everything in, which is good because, you know, these things get shipped thousands of miles in probably not the, you know, gentlest of conditions. And you wouldn't want any of these coming loose in transit, and then you plug the printer on and a new user can't figure out what's going on. It doesn't ever home, or the one stepper doesn't move or whatever. So they elected, probably rightly, to hot glue everything in place. So you have to get in there, and without cutting your board up and without cutting the wires up, you have to trim away the hot glue that's holding stuff in place. And it's usually only on the back side for these. You can kind of see where I shaved it. I have a little tiny X-Acto. Went in there and shaved it away. Once we change, we're going to change this entire board later in the quarter to a SKR board. In this particular case, it doesn't really gain us that much, or it won't gain us that much because this is already a 32-bit board, but I'm going to do it anyway. Now, we have to get that to unplug. And it's still probably got a little bit of glue holding it in. Sometimes we might have to get a pair of pliers down in there. I think there's glue in between these that is kind of holding this up. And while you're doing this, you have to be careful that you're not actually cutting any of the wires or nicking them or anything like that, because that could create new problems for you. I may go get a pair of needle nose pliers to get down in there. All right, this may look very not gentle, but I'm gonna hold the board as best I can and kind of wiggle. There we go, back and forth. Oh, I see. There was a little clump of glue right there that was holding us up. Now, it has happened to me in the past that this socket cover, like the receptacle itself, the plastic part, has come off the board. Don't worry if that happens. Like it might come attached to this. Not a big deal. All you have to do is slide it back on. The plugs themselves, the actual wires that are sticking up, the pins that are sticking up, they should stay attached to the board. Now, if they come off of the board, you do have some soldering ahead of you. And that's going to be a little more difficult. But don't worry too much if the receptacle, just the plastic part, if it slides off of there. There's nothing actually holding it on. It's just pressed on there. Now, we've got our old Z wires out of the way. In fact, we're going to remove the Z end stop here in a second. Here they are. These should be the correct order, but we don't know until we turn it on. And I noticed that in the process of that, I unplugged this. So let's plug this back in. This is not the, this is not made to fit this. So you're kind of relying on just a press fit in there. Let's just put this wiring back towards the back for now in this corner. So I'm just kind of putting it over in this area. There's a notch here for wires to go through. We don't need the old Z wires in there at all. So let's kind of get this back lined up. Try to not pinch any of the wires. Try to keep them out of the fan. Let's go ahead and put a screw or two in here. We'll finish it up later. I just don't want it flopping around. We'll put our little cover back on there too. but there's always a chance that we have to go back in there and check on our wiring. So we'll leave that. Let's either take this off entirely or drop it down so that it's not getting in the way of your homing. Because now we're going to want the BLTouch to do the homing. I think for now we'll just lower it down. Kind of like that. It should be well out of the way there. Okay. Let us go over to our firmware. It says it succeeded. So over here in the PIO build, if we right click on this folder, we can reveal in File Explorer. Open up over here. Inside this folder, we should have our firmware that we built today. So it looks like it's this one, 6/21/2021 at 8:36. So we're going to put this on our SD card, which, see if we can get our SD card open. Looks like it labeled it as G this time. Now remember, we've got all these other things. I'm going to go ahead and clear out a bunch of these older G code from where I printed the previous things. Let's drop that firmware onto here. This one. Notice all these others I have labeled as with a BAK extension, so they're kind of like backup files in case I ever need to go back to one of those. I can rename it and add a BIN. Remember the way that these newer boards work, as long as it sees a .bin file with a name that is never seen before, it will install that as the firmware. So all you have to do to upgrade your firmware, even if you want to go back to one of these old ones, you know, maybe I know this is the last one I was using that had the 5-point manual mesh probe on it, and so I could just change this to any other name and change BAK to BAN, put the SD card in, and it would install it over itself, over whatever was already there. So right now it's seeing this is a file name it's never seen before, and it has the BIN extension, so it should install this as our firmware. So let's eject this disk. Okay. And let's go over here to our printer. Put our SD card with the hopefully new working firmware on here and turn it on. Oh, that was good. I wasn't even thinking to show you that, but the probe extended 3 times and lit up a solid red. That is the self-diagnostic test that this worked, and it passed because it's not flashing or anything like that. So that's good. And then over here on our screen, we have firmware running. And all these question marks, it's not homed. So let's do the usual thing that I do with the new firmware is I home one axis at a time. So let's home X. That one shouldn't change. That looks good. Let's home Y. Okay. Now homing Z is going to rely on the BLTouch. First of all, it's going to rely on it actually extending the probe, and then moving the probe over the bed somewhere, so it's not like trying to probe somewhere off the bed, and then actually touching the bed and sensing it. So I'm going to try that. I would be ready to turn it off in case something weird starts happening, but home Z. Alright, so it moved to the center. That's good. Extended the probe, and it's moving down. I'm going to go ahead and trigger it early, and it did. Alright. Now, I'm going to do it for real. I'm going to do auto home now to do all 3 of them because I don't want it homed up in the air like that. So, that actually is working. So this is the safe home. You can also tell if your probe offsets are correct when it does the safe home and it probes in pretty much the exact center of your bed, which, I mean, maybe that's off a tiny bit, but that's pretty close. I think it's off the amount that my offset is. Like it's pushed that way a little bit and pushed that way a little bit. But now what I want to do is I need to get the Z height correct. So I'm going to see in here, let's see, is that in motion? I got to find it. Oh, this is the... This was the level bed option. So it's doing the 3-point, the 3x3 grid. That's the reason I switched off of this to begin with, is I wanted to do the 5x5 grid. But honestly, 3x3 is probably fine for a smaller bed like this. So when we are satisfied that this is working, we need to go into our slicer and actually activate it so that before every print, it will do this routine. So there's a downside in that it adds a little bit of time to your prints because it's going to do this routine every time. Right now it is probing the bed, but the bed's not heated, so it doesn't actually, it's not going to give me any useful data because the bed's not in its state that it's going to be printing at unless I print with a cold bed. I'm just more or less checking that it's actually working, which it appears to be. We do need to, fasten this wire out of the way so it doesn't tangle into stuff, and we're just going to do that with the zip ties they sent us. All right, so it did probe the whole bed. It did a 3x3 grid. Let's go. Oh, and the steppers are, let's release the steppers so I can move it around. So that's in motion, disable steppers, just to kind of move it out of the way. Let's see. Yeah, we still have time to do this. Let's go to Cura. I should have already opened Cura, but I didn't. So that we can add this to our slicer. Otherwise, it won't actually take advantage of it. Yeah, it is looking good so far. Normally, the biggest thing that I've always run into with these is those wires being backwards. I don't know that they're backwards every time, but I think every time I have done one of these installs, I've had to switch those wires around. I don't know why this is branded from Creality. This is a Creality board, so you would think that they would match them up, but for some reason they are always backwards on the ones that I work on. And what will happen is basically it won't power on. In fact, it could not even power your LCD screen on because you've reverse polarized the power on this thing. And I have turned them on before when they were backwards, and it didn't destroy the board or anything. I think that could be a potential. It didn't destroy the board or the sensor, but the sensor didn't work at all. And so if you run into that situation, then there's a good chance that those wires are backwards on your board here, or whether that plug into your board. If you run into the situation where it powers on fine and goes through the self-test, but when it goes to probe, instead of going down, it actually goes up, then usually the white and black wires are backwards. And I've had that before, but not in a long time. Usually, currently, those have been the correct order. If you tell it to sense the bed and it actually moves up, it's usually the white and black wires that are backwards. All right, we're in Cura. Wait, Cura right here. Let's get it on the screen. We need to manage our printers. So the summer 2021, that's the name of this printer. And manage printers, machine settings. So let's look at our startup G code. We've got all this stuff. Remember I wrote that zigzag purge line. We'll leave that in there, it's fine. I do remember that when we wrote this, there was a little bit of a problem in that it just wouldn't do it. I was under the impression that it didn't matter if these letters were uppercase or lowercase, but it did matter. So they needed it all be uppercase, and then it works. Let's see. So here's home all axes. This line here is when I was using the manual mesh. So we went in, we didn't have the BLTouch on there, and we manually probed the bed. I've got that commented out right now anyway for whatever reason. I don't even know why. So we do want that uncommented. And we want to add G29 that will probe the bed with BLTouch. So the G29 command, after you home everything, should go in and do all the probing for us and store the data and actually use the data to print on the bed. We can leave all of this the same. Yours won't have all of this unless you went and copied the code that I have. All this does is it does a zigzag purge line, and then it comes back with a straight purge line. If you are having issues with maybe your nozzle is not purging far enough, enough filament out, and you're having to use some of the skirt as a purge, which is fine, by the way. These E values here, so E3, E6, E9, these are the amount of material to cumulatively, the way I've got it set up here anyway, cumulatively send through the nozzle. So first on this line it sends 3 millimeters through the nozzle as it's moving that line from wherever it was to this endpoint 1025, and then it's at E6, so that's a difference of 3, so it added 3 more millimeters, and so forth. So you can, but what I'm saying is you can change the E value to spit more filament out if it's not purging very well. All right, that's all we have to do is add the G29 and then slice something. So I don't even know if I have a handy thing to slice. There's that fan guard. I don't want to print another one of those. Let's get something smaller. Where's the knob for the? Well, there's just a spacer. That's fine. Let's do that. Now this one is very tiny, and it's not going to take advantage of the fact that the bed could be all warped because it's just going to print in such a small area. But I don't want to print a giant thing. Let's preview it, make sure it looks right. So it's got a brim on it. Small objects like this typically do need a brim, otherwise they're just not enough material holding them to the bed. So let's eject our SD card and put our file on here and see if we can get this to work. Save to disk or save to removable drive. Eject. Let's go over here. This may be my currently most annoying piece, is trying to get that SD card down there. Print from SD. Oh yeah, I erased all the other files. I was wondering why there was only one file on here. Alright, so it's heating up the bed. Remember, I still want to add these. We may get to work on that a little bit. I want to see if we're going to get our our BLTouch to work. While it's doing that, I'm going to go ahead and kind of zip tie these out of the way so that we don't run the risk of this wire ending up in our print somehow. Oh, dropping all the zip ties. Let's do a couple of these. Obviously you can go in and do a much cleaner wiring job on this, but this will make it work for now until you want to do something nicer. Maybe print a cable chain or buy a cable chain. If you if you don't like the messiness of just having wires zip tied to it. Back here, I don't know if you've noticed, I don't even know if I can show it to you. Back here, there is a little holder that will hold this wire, or this bundle, kind of in place. Kind of like that. I don't ever zip tie it to that. I suppose you could, but it does kind of keep it out of the way. And then over here, I need a little bit more slack on my wire. We'll do something like that, and that should be fine. Basically, if you follow this bundle of wires, then that is a way you can route the cables, the BLTouch cables. Now, I currently have mine routed, you know, around in front here, but they could go around back and kind of be out of the way of everything. There's plenty of length of wire to do that. Looks like our bed is heated. Now we're heating the nozzle. I'm looking down in here. Some of our wires are sort of close to our fan. They won't actually hurt anything. What could happen is if they get in the fan, then they'll easily stop the fan from turning. And this fan is for cooling the steppers on the board itself. And you do want to keep your board cool. It doesn't even run all the time. It's on a temperature. You know, if it notices temperature getting to a certain point, it will kick in. So you do want to make sure that your fan is not being bound. Other thing they could do is just get in the fan and make a sound. That's annoying. Everything looks like it's going good so far. It's using the probe to do the Z-home. Now it should, and there's the G29 command for probing the bed. So it adds that amount of time to your print because it does go and probe the 9 different points, and I'd kind of like to change that to do 5 by 5. I don't mind the little bit extra time, but only if I'm going to do a larger print. And I don't know in this software how to change it to 5 by 5. I'll look around and see if I can find it, but it kind of looks like it's hard-coded in to be 3 by 3, and I haven't found where you can change it. It's usually in the configuration advanced, but I haven't found it yet. And the 3 by 3 for this size bed is probably fine. Let's see, I'm looking in the configuration advanced right now, and there are some options for probing speed and that sort of thing, which you might want to change, but I don't see one for the number of points yet. Alright, so I'm good with that. I'll stop the print. So what it's doing now, actually, I probably could tune it because it's really high off the bed. We never set the actual print height. So I'm in the menu over here doing the Z off step during a print, and I'm lowering it down quite a bit. I think we're close. A little more. So I had to lower it down 3.675 millimeters. And it should save that. I'm going to tell it, it should save that setting for the next time. If not, I'll have to remember to put that in there. But as it's, now I can stop the print. Stop print. Stop. All right. Because it doesn't really know. It knows the map of the bed, but it doesn't know how high above the nozzle it was probing. And you don't really know until you start printing, because each sensor could be slightly different in the amount it probes or when it triggers. Apparently this one is mounted so that it triggers about 3.7 millimeters before the nozzle hits the bed. And so it should be set up now that I printed and live tuned on the LCD the Z offset, and I was just turning the knob to move the print head up and down as it's printing until it was actually printing at the right height. I'm going to go ahead and save settings. I think I can do that. It should save it automatically, but I just want to make sure that it actually is store settings. There we go. Alright, so that should be all there is to installing a BLTouch on here. And we're going to release the steppers. Actually, I'm going to turn it off. We have 10 minutes or so. I want to see if we can get these installed, or at least one of them installed. There is one of these that's shorter than the others. The shorter one goes in the back left corner where you've got the strain relief bracket. So installing these is just, you know, releasing the knob here, hoping the screw stays in place. If it doesn't, then we'll figure out a way to make that work too. Let's see if we can get this one. Okay, and then we've got the one back here. All right, we got them all off. Now, just lift it up and take the spring out and put this guy in. Oops, without dropping it. So sometimes a little tricky to get all four of these at the same time. I'll move this out of the way. That's another benefit of having printed something like this up here. It's easier to move the Z-axis up and down if you need to. This one's being a little contrary back here. So you do be careful back here, because if these wires come loose, that's why this strain gauge is here. If these wires come loose from the solder, then you're going to have problems, and it could be dangerous fire type problems. If you ever get one of those wires where it is loose but still connected, then that will make a weak electrical connection, which makes it work harder to put the electricity into the bed, and you can end up with it pumps more and more current through there through the weak electrical connection, and that current will end up heating the bed up and potentially melting things back here. Hopefully just melting them and not burning things. All right, we just reinstall our screws. They do make kits that have new wheels on them. These work plenty fine. They make some aluminum ones. I did put those on the last printer that I did, but just because they kind of look cool. They actually are heavier, which you don't want more mass on these on this moving bed anyway, so you kind of want the lighter plastic wheels. Okay. So now I don't have as much compliance in my bed, but I'm adjusting for that by measuring the bed. And I think that overall is a better option. We're just going to kind of tighten it down to where I don't know that these screws, you can kind of feel if the screws are turning. These are not. I want one of the springs. So I am able to tighten it a little bit. But now we've got a pretty rigid bed. It still has some give from the wheels that are holding it onto the rail here, but it doesn't have the springiness of having springs in it. I just realized that I've been getting grease all over this thing, so feel that, clean that up. All right, so I think all I'm gonna do from here on out is just tidy things up. So I think what I'll do is I will route this, or I'll unplug it and route it back around that way so it's not around here. I'll probably remove the Z and stop completely. We don't need it in the way at all. And so I'll take that completely off. And I'll do another print because now that I've changed the height again, I probably need to do the Z offset again. Because it's a different height. Well, no, it's because the offset is based on this height, so the Z offset should be fine actually. That's the whole point of having a sensor, is that your bed, it detects the bed. I do want to check and make sure the bed is as level as it can be to start with, because even that these are solid, there is some give to them. So I'm going to check and kind of make sure that the bed is as level as it can be, and then we'll do some test prints, and next time we are going to do what I'm planning on doing is just talking about other types of printers, just an overview of the different style. We can't get into like every one of them printing, but we can look at I have a Delta over here that we can look at, an IDEX. We'll look at the Prusa just because it's a popular one, but it's the same style as this printer. I've got one that's water cooled down there that we can look at. So just some different styles. We'll look at the resin printers too, but I'm going to have a whole day for resin printers just because they do offer a thing that's very different from what we have here. In fact, while we've got 3 minutes, let me see if I can find something. All right, so this is just an aside, but I've printed in the past. These maybe last summer. Yeah, I think these were last summer. I printed up some high detail little miniatures, so little figures, just to kind of show what you can achieve with an FDM. So one of these is an Ender 3 and a resin printer. So this guy here is a resin print from a $200 resin printer, and obviously painted. They didn't come out colored. They were just I don't even know what color this guy. I think it was green when he started. So that's a resin print, and about 2 hours to print, maybe something like 2 hours to print this guy. This one though is an Ender 3 FDM printer. And you can still get very high detail. Again, it was painted after it was printed, but you can get very high detail, fine little, like his thumb is separate from his hand here. Actually, his fingers are separate. And you can get a really high level of detail even with an FDM printer that you might not think. No special nozzle. It had the 0.4 millimeter nozzle. There was nothing special about that printer. It's exactly like the one that we're working on this summer. It does take longer to print this guy on the FDM printer, maybe in the 6 hour range or something, where this guy you can print on a resin printer in 2 hours, and you can actually print maybe 3 or 4 of these guys in that same 2 hours, and one of these guys in about 6 hours. But just to show that you can get really fine detail from these printers if that's what you're trying to do. But all that to say that we will talk separately about resin printers, other than just what we mentioned tomorrow. I have a day. I don't know where I have it. I actually have it on July 23rd, but we could move that up if people are interested in it. All right, I will see you next time. We'll talk about some different printer types. If you have troubles with a BLTouch, let me know, and I will see if it's something I've encountered before. Again, the main problems I've encountered are the black and white wire being backwards, and it causes the touch the sensor to move upwards instead of down, and it doesn't trigger anything. Or the red and blue wires, ground and power wires being backwards, and that one, it just shuts everything down, and it could potentially harm things. I don't know, just it didn't on mine, but to be sure, what you should do is you should go in and look at this pattern on your board and make sure that that matches with the pinout of your sensor. So make sure that those are lined up. All right, I will see you next time.